Give the next heading weight. Now, what is meant by weight? Try to see the scenario. What is meant by weight? Weight is defined as gravitational force acting on the object. What is meant by weight?
Gravitational force acting on the object.
Means force due to gravity. So, in other word, gravitational force is nothing but what? What is meant by gravitational force? What is the meaning of gravitational force? Force due to gravity of the earth. Means suppose the force which is due to on us due to the gravity, we will say it as a weight. So weight is nothing but the what? Gravitational force acting on the object. And what is meant by gravitational force? Gravitational force means force due to gravity. And mathematically, weight will be equal to what? M into G. What mathematically what is meant by what is meant by weight? Weight is
M
equal
into
to
G.
M into
Mass.
G. Mass into G. And what is meant by G? G stand for what? Acceleration due to gravity. And that will be its unit is what? Its value is what? 9.81 meter per second square. So that is what a weight. So please write down up to this point,
Yes.
and then we will see further discussion about the weight.
Okay.
Now try to see the scenario. So you got the meaning of weight. What is meant by weight? Gravitational force acting on the object, and gravitational force is nothing but what? Force due to gravity of the earth. And what is mathematical relation for weight? Weight is equal to what? M into G, and G stand for what? Acceleration due to gravity, and G value is what? 9.81 meter per second square. So that is what a weight. Now how the weight will act? Try to see the scenario. Yesterday in one numerical, means in last lecture, we have seen a word center of gravity.
Yes.
So now what is meant by center of gravity? We will see. Weight of the object always acts vertically downward. Try to see the scenario. How the weight of the object always act? Vertically,
Downwards.
vertically downward. And now what is meant by vertical? So these lines for us, see this reference line for us, horizontal lines. So perpendicular to that horizontal line will be our vertical. So weight
Yes.
of the object always acts vertically downward through the which point? Through the
Center of
center
gravity.
gravity. So weight of the object always acts vertically downward through the which point? Center of gravity. Now there are two ways we can denote a weight. Means weight, we will denote weight by what? Mg. So weight is
Yes.
for us mg, mass into acceleration due to gravity. So g stand for acceleration, g stand for center of gravity. So weight will be what? How weight will be the scenario? We can show like this: going towards a G vertically downward, or going away from the G vertically downward. Both the scenario is the similar scenario. So please write down this discussion. So in this
Yes.
way also we can show the weight, or in this way also we can show the way. Both are the similar scenario. Please draw this figure. Now we will see the example. Try to see the scenario. We will see the example how we denote the weight. See, suppose this is our object. This is what our object. This is what a block. We have this is what a block. This block is on what? 1 minute, I will make this block properly. So this block is on what? One inclined plane. This is what an inclined plane. Now sometimes some people may denote weight like this. Is it a weight to show the weight proper way? To show the weight
No, sir. It should be in the downward direction.
vertically downward.
Yeah.
Vertically downward. So this is the proper way to show the weight. So in this way we can show the weight mg through the center of gravity, or towards the G, or away from the G. Both are the same way. So please write down this example. Both the scenario we can show weight like this, or we can show weight like this. Any doubt in this discussion? You got the meaning of weight, sir?
Yes, sir. Yes.
Now try to see the scenario here further, what we have to study further. Now give the next heading, equilibrium. Give the next heading, equilibrium. Now what is meant by equilibrium that we are going to study? So equilibrium means what? What is meant by equilibrium? Equilibrium means what? State of balance. What is meant by equilibrium? Equilibrium means state of balance. Now if any object is in equilibrium, then resultant force and resultant moment on that object is what? So we have seen resultant force and resultant moment in one numerical. So that resultant force R and resultant moment M on that object will be what?
0.
0. Then we will say that object is in equilibrium. So if object is in equilibrium, then what is going to happen? Resultant force, if any and resultant moment will be what? 0. Now how to identify any object is in equilibrium? When does we come to know that? We have seen if a object is in equilibrium, then resultant force and resultant moment is 0. But how to identify the object is in equilibrium? When does we come to know that object is in equilibrium? If object is stationary or moving with constant velocity. Try to listen my word carefully. If object is what?
Stationary,
Or
moving with constant velocity.
velocity, then object is said to be in what? Equilibrium. Means velocity is 0 or velocity is constant. In that case we will say object is in equilibrium. When object is in equilibrium, then resultant force and resultant moment on that object is 0. So you got it, what is meant by equilibrium? Equilibrium means what? State of balance. If any object is in equilibrium, then resultant force and resultant moment on that object is what? 0. If object is stationary or moving with constant velocity, then we will say that object is in equilibrium. That is, means constant velocity means what? V constant. Or stationary means what? What is the meaning of word stationary? Velocity is 0. So whenever V or 0 or V constant, object is in equilibrium, and if object is in equilibrium, then resultant force and resultant moment is what? 0. So please write down this discussion about equilibrium.
Yes.
Don't write down the below heading, just write down up to equilibrium. Now try to see the next point here. So suppose any coplanar, now if any coplanar concurrent, non-concurrent, coplanar means same plane, non-concurrent means not passes through the same point. So if
Yes.
any coplanar non-concurrent force system, if coplanar non-concurrent force system is in equilibrium, then it satisfies the following equilibrium equations. If any if any coplanar non-concurrent force system is in equilibrium, then it satisfies the following equilibrium equations. What are the following equilibration is going to satisfy? Rx. What is meant by Rx? We have seen summation of forces in x direction.
X direction.
That will become what? If resultant force is 0, we have seen equilibrium means what? Whenever object is in equilibrium, resultant force and resultant moment is what? 0. If any resultant force is 0, then by default its component will also be what? 0.
Yes, sir. 0.
So Rx will be what? What will be the Rx? Summation of forces in x direction equal to what?
0.
0. Here sign convention is what? If it is right side, if it is going right side, positive. If it is going left side, negative.
Yes.
Then summation of forces in y direction means Ry. What is meant by Ry? Summation of
forces in y direction and it is 0.
equal to 0. Here upward positive we will take, and downward will be what? What we will take? Downward negative. And third relation is what? Summation of moment. Here
Yes,
what?
sir.
Summation of moment at any point equal to 0. It is not a many point. It is what?
Moment.
Moment at
Any point.
any point. We can take any point, but though we said any point, generally we will not take any point. We will see which point we will select.
Yes.
So summation of moment at any point will be equal to what? 0.
0.
Taking clockwise as what? Positive.
Positive and anti-clockwise is negative.
Anti-clockwise as what?
Negative.
Negative. So please write down this discussion.
Yes.
So now we have seen what? Equilibrium of coplanar non-concurrent force system. Now the next point will be what? Equilibrium of coplanar concurrent force system. So whenever we have to deal with equilibrium of coplanar concurrent force system, there we have to deal with only two equilibrium equations. One will be what? Summation of forces in x direction equal to 0 and summation of forces in y direction equal to 0. We don't need this moment equilibrium equation. So this is what? So whenever we have any coplanar concurrent, what is meant by coplanar? All the forces same plane, and concurrent means passes through the same point.
Yes, sir.
So Rx will be what? Summation of forces in x direction equal to 0. Ry means what? Summation of forces in y direction equal to
0.
0. Please write down this discussion. Now try to see the next point. Next point is quite very important. Now equilibrium of coplanar concurrent 3-force system. Means it is a coplanar concurrent, but how many forces will be there?
3 forces.
Only 3 forces there. So if coplanar concurrent, try to see this sentence. If we have a coplanar concurrent 3-force system and it is in equilibrium, then these 3 forces form a closed triangle. Try to see the scenario. Whenever we have what is going to happen? Whenever we have a coplanar concurrent 3-force system, whenever we have what?
Coplanar concurrent 3 forces system.
Coplanar concurrent 3-force system and it is in equilibrium, then these 3 forces will do what? Form a closed triangle. So now just have a look at this drawing. Just have a look at this drawing. Here on this object, how many forces are there? F1,
3 forces.
3 forces. And just we will assume that these 3 forces means this system is in equilibrium. So whenever these 3 forces, coplanar concurrent force system is in equilibrium, then these 3 forces will do what? What they will do? They will form a closed triangle. So what is meant by closed triangle? See, first of all, what we are going to do? We are going to draw F1, see F1. Then this will be what? F2. Try to see the scenario here. So what we are going to do? 1 minute, I will erase this drawing so that you will get a more detailed idea what I am going to do. So what is meant by closed triangle? How they will form a closed triangle? Try to see the scenario. So this is what our force F1. See, this will be what our
F1.
force F1. So here we will have a force F1. Where force F1 ended, from that point what we are going to draw?
F2.
Force what?
F2.
So here we will have what? A force what?
F2.
A force F2. So in this way here we will have a force F2. Then what we will have? What we are going to do? And then closing side of this triangle will be what? See?
F3.
F3. See, all the directions. See, same. Here F1 direction. See here F1 direction. Same.
Yes.
Here F2 direction and here F2 direction.
Yes, yes.
You are getting my point?
Understood, sir. Understood, sir.
So in this way, these 3 forces will form a what?
Closed triangle. If
But
it is
when
in
they are going to
equilibrium.
form a closed triangle, remember the point?
Yes.
When these 3 forces will do what they will do?
Closed triangle.
When they will form a what? Closed triangle. So whenever these 3 forces form a closed triangle, when they are in what? Equilibrium. Try to see the scenario here. So here, 1 minute, we will assume. So here, opposite to the F1, this angle we will consider as a what? Theta 1. Opposite to the F2, we will consider this angle as what?
Theta 2.
And opposite to F2, what this angle we will consider as what?
theta 3.
Oh, I have considered wrong force here. This must be what?
F3,
F3. So this F3 opposite to F3 will be what?
theta 3.
So this angle will be what? Theta 3. Then by sine rule, what we can say? F1 by what?
F, okay.
F1 by sine theta 1.
F1 by sin theta 1, F2 by sin theta 2, F3 by sin theta 3. Sin rule.
So you got this one?
Yes, sir.
Equilibrium of coplanar concurrent 3-force system, and how we are going to deal with this one?
Yes, sir.
Please write down this discussion. So any doubt in this discussion? You got the meaning of coplanar concurrent 3-force system
Yes, sir. Yes, sir. Yes, sir.
and what they are going to do?
They will form a closed triangle, sir. Repetition equilibrium.
They will form a closed triangle. Correct. Very good. Now the next point will be what? A centrifugal force. What is the next point?
Centrifugal force.
What is the centrifugal force? Centrifugal force is denoted by what? Fc, F suffix C. Now what is meant by centrifugal force? Try to understand the point. What is meant by centrifugal force? Centrifugal force is an internal resisting force. What is meant by centrifugal force? Centrifugal force is an internal resisting force which opposes what? Circular motion of the object. Whenever there is a circular motion of the object, we will have what? One internal resisting force, and that internal resisting force is nothing but what? Centrifugal force. And how it will act? It always acts radially outward. How centrifugal force always act? Centrifugal force always acts radially outward. So what is meant by centrifugal force? Centrifugal force is an internal resisting force which opposes what? Which motion it is going to oppose? Opposes the what? Circular motion of the object. And how it will act? It always acts radially outward. So that is what a centrifugal force. Now with the help of drawing, we will try to understand more. So now try to see this drawing. Suppose there is a one object. Just have a look here. This is what object. This object is moving in this circle, this dotted circle. Observe this one. We have object. So here this black one, this black dot will be the different position of the object.
Same object.
Different position of the object on this circle. Suppose object is here. So
Yes.
what I told you, whenever this object moves in a circle, which force? Internal resisting force on that object? Centrifugal force. And how the centrifugal force will act? Centrifugal force always acts what? Radially outward. Means if you draw one dotted line from here, so in this way, centrifugal force, how it will act? Radially outward. And always remember that suppose object is at this position, then velocity is what? Always tangent to the path. How the velocity? Velocity is always what?
Tangent to the path.
Tangent to the path. Now when object reaches here, suppose at this position, just at this black dot position, how will be the centrifugal force? See, radially outward. Means we have drawn a dotted line from this center position. So centrifugal force always acts radially outward. And what I told you, velocity always tangent to the path. Suppose object reaches here, see, centrifugal force again acts radially outward, and velocity at this position tangent to the path. So in this way we can show centrifugal force always acts what? How it will act?
Radially outward.
Means see this along the radius, you got this one?
Okay, sir.
So before going further, give the heading centrifugal force Fc and write down the definition of centrifugal force and draw this figure. Now try to see the next point. So we have another relation for Fc. Another relation for Fc will be, so now we are going to see a relation for Fc. Relation for Fc will be what? mv square by r. This is one relation for Fc, means centrifugal force, and another relation for Fc is what? mr omega square. Now m means mass, v means velocity, r means what? Radius. Now here there is a new term, angular velocity, omega. We will see angular velocity in more detail in rotational motion chapter. So Fc is what? mv square by r. That will be equal to what? mr omega square. And that omega angular velocity will be equal to what? 2 pi n by 60. And what is meant by n? N means what? Rotational speed. Means in every revolution, how many? Means in per minute, how many revolutions of that object is going to move. So please write down this discussion of the Fc. Now write down this note, sir. Velocity is what? Always what, sir? Tangent to the path. Velocity is what?
Always tangent to the path.
And here we derived from mv square by r. Here we derived from velocity is always tangent to the path. And remember, v is equal to what? Omega into r. What is v is equal to what, sir?
Omega into r.
And here we tried to derive. Here what we did? Here we tried to derive by using mv square by r. We tried to derive mr omega square, sir. So here what we did means mv square by r. Fc we have seen mv square by r. So v means what? Omega into r. So whole bracket square. So
Yes.
So we tried to derive this relation. Please write down these two note.
Yes.
Means by using this relation of Fc, we try to derive another relation of Fc.
Understood.
Please write down. And remember, what is velocity is always tangent to the path. And that's what we have shown on this drawing. See, velocity is what? Tangent to the what? Tangent to the path.
Yes. Now,
Now try to see the next scenario, sir. Here, what we have to do? What we have to do? And how we are going to approach the things further. Next thing is what? Give the next heading, types of equilibrium. In first type of equilibrium is what? A stable equilibrium. And how it is associated, related with a ship, we will see that one also. How it is related with the ship, that is also we are going to see. Now just observe, this position of this ball is in what? This position of the ball is in stable equilibrium. This position of the ball is in what? Tell me.
stable equilibrium.
And how does we come to know that this position of the ball is in stable equilibrium? Try to understand point. Suppose we shifted ball from this position to this position. Suppose due to some external force, we shifted ball from here. We shifted ball here. But once we remove that external force, ball automatically come back to its original equilibrium position. So this position of the ball, we will say it as a stable equilibrium. Now the same scenario with the ship also. Suppose we tilted the ship. Means due to bad weather, what is going to happen?
The rolling of the ship.
Due to bad weather, suppose there is a rolling of the ship is going to heel. But if the ship is in stable equilibrium, then automatically ship will get what? Upright position. Automatically. So then that scenario means what? That scenario means what? Stable equilibrium scenario. So you got it, what is meant by stable equilibrium scenario?
Yes, sir. It's coming back to its own position automatically.
Without any external force. Means we don't have to apply any force. So the forces means there are two forces on the ship. One is a weight and another one is a what? Buoyancy force. They will manage automatically and they will bring back the ship to the equilibrium. That is what you have to understand what is meant by stable equilibrium. More detailed things you will study in naval, but that is what important to us in mechanics. That is only things related with mechanics. So now, so what is the definition? If object shifted from its equilibrium position, what is we can say? If object shifted from its what? Equilibrium position due to some external force, and it come back to its original equilibrium position automatically after removal of external force, then object is said to be in what?
Stable equilibrium.
Stable equilibrium. You got my point?
Yes, sir. Yes, sir. Understood, sir.
So this is what a stable equilibrium scenario. So please write down this discussion. Stable equilibrium, first type of equilibrium. Now second type, no so stable. Then another one will be what? Unstable. So in an unstable situation, so this is the unstable. So this position of the this mass, this ball, this position of this mass will be what, sir?
The position of this mass will be stable, sir.
Ha. This mass, this position of the mass, we will say it as in this mass is in what? Unstable equilibrium.
Okay.
And how it is unstable equilibrium? If we shifted this mass from this position to this position due to some external force, then what happened? It never come back to its equilibrium position automatically, and its new position means what? It never comes back to its original position automatically, sir. And this situation is what? Is not an equilibrium situation after removal of the external force. You got this point?
Yes, sir. Yes, yes.
So means what? See, here in stable equilibrium scenario, if you observe, it is coming back automatically. So this position is what? Stable equilibrium position. But this position is what? This position is what? Unstable. Unstable means what? If object shifted from its equilibrium position due to some external force, it never come back to its original equilibrium position automatically after removal of external force, and its new position is not an equilibrium position. So this position is not an equilibrium position. Remember my point.
Understood, sir. Understood, sir.
Huh.
It will not come back after removing the external force also. It will not come back to its original
Position automatically, and this new position is also not a equilibrium position, because at this position object is not a stationary and not moving with constant velocity. You got this point? You got the meaning of unstable equilibrium?
Yes, sir. Yes, sir. Yes.
So please write down this second point, unstable equilibrium, and write down the definition also. Draw the figure. These types of equilibrium they have asked us in the exam.
Understood, sir. In theory questions are
Just 2 or 3 mark theory question.
Okay.
It happens rarely. So in one of exam, December 17 exam, they ask this question.
understood, sir.
Now third type of scenario means, see, first of all, before going further, but I want to explain you unstable. Means suppose due to bad weather, suppose ship get hills. If it is unstable, then what is going to happen? It will not come to upright position. What will happen? It becomes what? Capsize. So that is
Understood.
that is meant by unstable. But what is meant by third scenario? Third scenario is what? Neutral equilibrium scenario. So if you observe in neutral equilibrium scenario, if object shifted from its equilibrium position due to some external force, see, here we are going to shape, so this position of the object is what? Neutral equilibrium situation. This position of the object is what?
Neutral equilibrium, sir.
Neutral equilibrium position. Suppose we shifted object from here to this position, then what is going to happen? This position is neutral equilibrium, and this position also a what? Neutral equilibrium position. Means if object shifted from its equilibrium position due to some external force, it never come back to its original position, but its new position is what?
Equilibrium, sir.
Position is an equilibrium position. In case of unstable, here also not coming back to original equilibrium position, but new position is not equilibrium. But in case of neutral equilibrium, what is going to happen? This position will be what? Neutral equilibrium.
Yes, sir. Yes.
So you got the meaning of, so whenever ship is in neutral equilibrium scenario, what is going to happen? If ship get hills, it will remain in that position only. So that situation means what? A neutral equilibrium scenario. Suppose if you remember, if you study in naval, when GM is positive, metacentric height positive, you are going to study all these things in naval. GM positive, then stable equilibrium. GM negative, unstable, and GM 0 means GM stand for metacentric height. GM 0, then neutral equilibrium. You will study all these things in your naval. So that time you
Yes.
should remember this point in your mind.
Yes, sir. Yes, sir. Yes, sir. Yes.